A fourth definition, order versus entropy, that life creates local order. But of course, snowflakes do that exceedingly well. And so I think we're left with only one possible definition without contradiction. The notion that life is autonomic, exhibiting pattern recognition, and self-design. The thing that fascinates me most about the origin of life is that our common refrain, define your problem, how can you possibly study the origin of life if you don't know what it is, simply doesn't work with the origin of life. It's this big, hairy problem that requires us to accept the unpredicted nature of innovative problem solving. So what this then requires is that we look for another model than the conventional top-down, state your problem, clarify your goals, define your method, approach to problem solving. And I think that the origin of life has something to offer on that question. So first, pattern recognition. And I want to clarify that I'm using pattern recognition in the most general sense. In other words, the full spectrum from the key recognizing a lock that it fits simply by morphology to higher level consciousness. Francis Crick, co-discoverer of the structure of DNA, had a metaphor. He became very frustrated with all of the theorists trying to calculate the probability, the extraordinary improbability of the origin of life. And he said, well, just imagine a card game where you deal out all 52 cards to 4 different people, and there's a sequence of 13 cards that represents life. What is the probability that any one of those 4 players would get that sequence of 13 cards? Well, it's extraordinarily improbable. And the point that Crick was trying to make is that we are thinking about this problem in the wrong way, and that, in fact, we need to throw out our preconceptions that science is about accurate prediction, and, in fact, look at the role of pattern recognition. So I borrowed Crick's metaphor and used it in a slightly different way. Supposing that you deal out only 7 cards to each player and put the deck in the center. And so then as they play the game, they draw a card and they discard a card. The card that each player draws is the wild card, the random variation element. But the card that that player discards is the result of pattern recognition of a pattern emerging and evolving in his hand. I think that that's a more visual metaphor for the way that the origin of life might have occurred. So the complexity of this enormous field that crosses chemistry, physics, biology, paleogeology, information theory, all sorts of thinkers have been fascinated by this problem. And often, people who are also fascinated by the nature of consciousness who are working on that as well. And so the question is, how do you take this enormous complexity and find some level of conceptual coherence? What brings all these little pieces of research together? And of course, there's some clustering. One major area is all the researchers looking at replication, what they call the RNA world. And most of those researchers at this point have backed up to say whatever begat the RNA world. In other words, it is really extraordinarily complicated and could not have been the origin of life. And so possibly a simpler assumption would focus not on replication, but on simple persistence of life in its surroundings. And so there's another cluster of researchers working on metabolism. And an interesting observation, first made by Erwin Schrödinger and later by Freeman Dyson, is that there are many more German researchers working on metabolism. And both of these physicists speculated that the reason might be that the word in German for metabolism is Stoffwechsel, in other words, matter exchange. I mention that simply to kind of clarify what I mean by the impact of our language presets on how we solve problems. So in any case, metabolism is also extraordinarily complex. And so researchers, the challenge was Occam's razor. How do you actually make this complicated thing simple? And so there's another large cluster of researchers working on enclosure. and that actually is very complex as well. One of the most distinguished of those researchers, David Deamer at UC Santa Cruz and also here at NASA Ames, unfortunately couldn't be here today, has done a lifetime of work on what it requires, the whole idea of self-organization and what it takes for membranes to start to self-organize. But again, the question is, what would bring these pieces together? What is the conceptual integrator, and what is the problem-solving model that makes this complexity make sense? And I suggest that the simplest way to diagram this challenge is not as a tree top-down, but as a spiral converging from blurriness and incoherence into focus. And so the question is, what is that focus? And I think that that focus is autonomy and pattern recognition. So this language preset pattern recognition, if one asks what begat, whatever begat that assumption, in all three cases, the replication first folks have the problem that replication requires something to replicate. Of course, Karen Smith has solved the problem that replication could be first life if, in fact, it started in non-life and gradually transitioned into life. But the question is, what is that tipping point? How do you define the moment when non-life becomes life? The metabolism first thinkers also have a problem. Life would need the capacity to recognize what to metabolize into what. In other words, an agent to determine how to acquire and expend energy, how to play the game of life. And finally, even the enclosure researchers have the problem that life needs the capacity to recognize what to enclose, what to define as self, and what constitutes other, what to discard in the game of life. So there is, at Jack Szostak's lab at Harvard Medical School, is working on this hard problem in a way that I think illustrates the points that I've just made. And what I find particularly intriguing about the way that his lab is working on this problem is, first of all, they are working as synthesists. In other words, they are scientists thinking like designers about the problem of the origin of life. And so on the one hand, they are conducting these very intricate laboratory experiments. And again, I have to resist the detail of this. And on the other hand, Szostak is really creating a grand synthesis of a complexity of theories into a single coherent theory for the origin of life. His laboratory will probably, is right on the verge of synthesizing life. You may have seen some news about that this summer. And it will probably happen soon. And Jack Szostak helps us out of our defining problem when he says we can carry out science without locking down our definition in advance. If we locked it down, we might miss what we should have looked for. So this concept of coevolution of definition and problem solving seems fundamental to work on the origin of life. So I want to suggest a first incomplete assumption.